everybody. Today we'll be taking a look at LeetCode problem number 20, valid parentheses. So let's get started. Given a string S containing just the characters opening and closing parentheses of various different types, determine if the input string is valid. An input string is valid if 1. Open brackets must be closed by the same type of brackets, 2. Open brackets must be closed in the correct order. So let's just look at through some of the examples. Example 1, yep, that's clearly valid. We have an opening and closing parentheses right after one another. Example 2, another valid, because we have 3 different types of opening and closing parentheses. However, they're in the correct order. 3 is invalid because we have opening and closing parentheses, but they are of different types. 4 is invalid because we have opening and closing parentheses, but they don't have the proper nested structure. And 5 is valid because we have both the opening and closing parentheses, but they do have the valid structure. So let's now try to see if we can think of an approach to solve this problem. So we can see that clearly after the last opening parentheses, it must be followed by the same closing parentheses. So what this means here is we have this opening parentheses here, and the closing parentheses followed right after it. And same goes for example 2, which is another valid one. But it gets a little more tricky when we look at example 5. So over here, these are followed by the incorrect closing parentheses, so we know clearly right away they're invalid. However, for example 5, we have this opening parentheses here. However, the first closing parentheses that follows it is the square one here. So what we really want to do is we want to keep track of the correct opening parentheses we're looking at. So what that means is if we start in this string here, when we're looking at this first curly brace, then we come to the square bracket, we no longer want to consider the opening parentheses as the curly brace, but as the square bracket. So when we see the closing square bracket, we know the previous one was invalid. Now we're no longer looking here, and we shift left, and we're looking at the last one, which is the curly brace. And then when we move forward, we see the curly brace again, the closing curly brace that is. Then we know that there was an opening curly brace before it, and that is valid. So an easy way to navigate this and make sure we're keeping a track of the right character at the right time would be by using a stack. So let's remember what a stack policy is. A stack policy is LIFO, last in, first out. And what this means here is we're going to look at the first opening parentheses, and we're going to push it onto our stack. We see another opening parentheses, we're also going to push that onto the stack. And then whenever we encounter a closing parentheses, we are going to pop our stack and see if the element that comes back is a corresponding opening parentheses. So in this case here, we're going to come to the ending square bracket, we're going to pop our stack, and we're going to see, okay, the last character in our stack was the opening square bracket, so we know this is valid. And then we move forward, and we encounter another closing parentheses. That means again we pop our stack, and if it's the same corresponding opening parentheses, in this case the curly brace, we know it's valid and we move forward. And then we can see here why in example 4 using this method it would return false. Because as here we're going to pop this parentheses into the stack, we're going to pop the square bracket into the stack, and then when we encounter a closing parentheses here, we're going to pop our stack. However, instead of seeing the correct opening parentheses, this first one here, we are going to see the square one instead. In that case, we know this is an invalid string and we return false right away. And then we just have to consider some edge cases, such as there might be more opening parentheses than closing parentheses. So that means when we finish iterating over the string, we also want to ensure that our stack is empty. Because if it's not empty, then we know we have some opening parentheses that did not find a closing parentheses match. And then the other case is, before we go pop our stack, we want to make sure there are actually elements in our stack. So if we get to one of these nodes here, and we try to pop our stack and it's empty, then right away we know by default that there was no opening parentheses to complement this closing one, and we should return false right away. So let's begin by coding our solution out that we just spoke about. So the first thing we want to do is we want to declare our stack, and we're going to use the deck collection, so a double-ended queue. In this case here, we're going to append to the right of it, and we're going to pop from the right of it. And in that way, it's going to function like a stack would. Then let's iterate over all the characters in S, so for C and S. And then if C is equal to any of the opening brackets, the 3 ones we have valid, what we want to do is we want to push this onto our stack. So stack.append C. And this is going to push it to the right of our stack, or the right of our double-ended linked list, sorry. Now, if this isn't the case, then what we want to do, if you remember right, is we want to pop our stack and check if the character that's popped is the corresponding opening parentheses to the now closing parentheses we're looking at. So before we do that, we want to mention one of the edge cases we spoke about, the one where if our stack is empty. So else if the length of our stack is equal to 0, meaning it wasn't one of these brackets we were looking at, so by default we have to be looking at a closing parentheses, but our stack is empty, meaning we also have no corresponding opening parentheses, so we just simply return false. Otherwise, what we want to do is we want to pop our last element in our stack, and what this is going to do is this is going to be the last opening parentheses that we saw. And what we want to do is if C, right, so if the character we're looking at, if it's equal to the closing parentheses, right, and the last bracket here does not equal the corresponding opening parentheses, or the other 3 options, right? So let's just go through them real quick. So what I might do, just because we're running out of space a little bit, is I'm going to close the question here, just so we have more space to look at the solution. So right now, if it's going to be the character we're looking at now is the closing square bracket, and last bracket does not equal the corresponding opening square bracket, and then finally, or C is equal to the curly brace, and last bracket does not equal the corresponding opening curly brace. So if this condition is met, meaning the character we're currently looking at, right, which is a closing bracket by default now, after it went through the first check, is not one of the corresponding opening brackets, we want to return false. We want to do this over the whole string. And if we can do that, once we are out of it, the last thing we want to check is if our stack is equal to 0. And this is because if we still had elements in our stack, that means we had opening parentheses that never found appropriate closing parentheses, and that wasn't caught into our false checks here. So an example of such strings would be, for example, like this, right? So a bunch of opening parentheses, and this would come through these checks all fine. But once it comes out of here, our stack would have a size of 4 for these 4 brackets. And that's the case we want to catch here. Let's try submitting that. We have a slight error right here. So the character we're looking at should actually be the closing parentheses, and our last bracket should be responding to the opening parentheses. So let's try submitting that now. And there we go. 20 milliseconds faster than 99%. And we have solved the problem. So this here is a bit long. If you look at the solution, we could make this a bit simplified. So the way we would have simplified this is if we just had a dictionary, right? Let's just call it like characters, and we initialized it to be, if we are looking at the closing parentheses curly brace, that should correspond to the opening parentheses, right? So now that we have this dictionary here, we can condense all this logic a little bit further. So all we have to do is else if length of our stack equals 0, right? So if it's empty and we're currently looking at an ending bracket, that means we should return false. Or if characters, right, at the current bracket we're looking at does not equal stack.pop, return false. So what this is doing here is it's just following the same mapping as before, but we're condensing it from a dictionary. So instead of doing each of the checks individually for each of the opening and closing parentheses, we're just simply feeding in the current closing parentheses we're looking at to our dictionary. We're getting back the correct type of opening parentheses we should be looking at. We are popping our stack and seeing if that is what is there. If it isn't, we return false. And then we do the same check at the end where we check the length of the stack to be 0. And there we go. this one passed as well too. So hopefully you guys found this informative and educational. If you guys did, please consider liking and subscribing, and see you guys next time.